Hello there. Sorry about that. Alright. So, as usual, I'm going to be talking about big cube patterns. And particularly in this video, I'm going to be talking about double patterns. Yeah, before it was a little bit tricky as to the name, but yeah, I think I'm going to settle with double patterns now. Anyways, what's this double pattern? Well, let me just show you this real quick. What is it? As if you remember from my last video, here it is. I talked to you about two-sided, reflective, symmetrical, three-colored patterns like this one. I have here on my 3x3. I hope you can see it. The lighting. Hope the lighting's good enough. But yeah, anyways, same pattern on the other side as well. In this video, I'm going to be kind of throwing that out the window. So you see this wonderful pattern here. Flip it over. Completely different pattern. That's what I'm going to be sharing with you. But something else noteworthy. So I told in my last video. What is it? If you notice, on this closer edge to the key corner, it's not reflective symmetrical. For example, you can see here the green here. You don't have that on the other side. Whereas here on this back edge area, what is it? It's reflective symmetrical with these 3 greens and then 2 reds evenly apart, but not reflective symmetrical. In this video, well, in order to, we have to keep that if you want the same pattern on the other side. Back edge has to be reflective symmetrical. But in this video, we can throw that out the window. Because, for example, this is a even Rubik's Cube. And from this orange piece here, there's only 1, not 2, to make this back edge reflective symmetrical. And not to mention, there's orange here, but not over here. And, but by doing so, it does change the other side. Whether that's good or bad, I'm leaving that up to you. But anyways, really cool. I hope you'll enjoy that. What else is there? And then something else cool I noticed is that, see here, we got this another really cool pattern here. It's like a spiral pattern, and yet if you flip it, it looks solved. These patterns can also do that. What is it? The issue though is, the back edge area has to be clean, I guess, completely solved, and this key corner has to match the back edge as well. But anyways, so yeah, you have this whole area to play with, except for the center piece. But this is an even cube, so we don't have to deal with that. But yeah, anyways, here I showed you some of my big cubes their patterns, but also you can work on smaller cubes too, like this 4x4. Really nice pattern. As you can see, the back edge isn't reflective symmetrical, and if I were to flip it over, you'd get this pattern. And I don't know, and in a way, almost these smaller cube patterns can seem a little bit cooler because they're more simpler and more interwoven, if you will. I don't know, I'm running out of words there. But whereas with bigger cubes, you can make more complex patterns and more detail. So anyways, that's that. I also made a 3x3 pattern like this one. It's really cool. And then on the other side you get this. So it's almost like the anaconda, except with this piece being orange. So that's kind of cool. Anyway, the let's jump into the algorithms here. I hope I just now actually I reprinted it because I changed one of the patterns. I'll get into that in a bit. So if you haven't already, I recommend you take a picture. If you have already, you should probably take a picture again anyway, because I changed it a bit. So let me show you my this is the old one I've been using. It's a little bit more wrinkled, and also if you notice here, these last two algorithms for the three colored patterns, I would discuss that in this video, but then I don't know, after doing it a bit, I realized that it's absolutely terrible on big cubes. It's not which is kind of sad too, because these are really good patterns for big cubes, but you know, the algorithm didn't really work. So I redid the algorithm here. It's does the same thing. It's just from a I don't know, different moves. Well, kind of the same. It's a different rotation. Yeah, different angle. So I'm gonna be getting into that. So yeah. Thing is, two of these this video I should really mention. This video gets a little bit technical, if you will. Might get a little technical. I have a little bit of difficulty with it even. So I highly recommend that you watch some of my older videos, like my last two. Yeah, my last two videos, because this video kind of builds on that. It's not a founding stone, if you will. I don't know. Yeah, you might get a little lost. Also, what else is there? Lots of commutators and, again, algorithms. So that gets into cube notations. Don't know what commutators are, or notations, or cube notations? Look them up. I'm not going to get into that right now. This video is going to be long enough already. Anyway, so yeah, let me just solve this real quick. Alright, so, yeah, I'm going to go over these, let me see here. In this video, I'm going to be talking about these 6 algorithms, so get a good picture of that. So let's start with these two, ones that start with the X. Is that X prime, I guess? The rotation move. So, let's see here. As usual, I like to, first step, I guess, first of the first, is you got to pick a key corner. I like to pick red, yellow, green. It's my key corner. So, with your key corner, you always keep it on the top right. And these algorithms, take place with the key corner on the top right. With this algorithm, though, it starts at the next prime. So that's, you move the cube down, so the key corner is on your bottom right. Okay, so, again, this is also a commutator, and it is actually a little bit tricky to get a hang of if you memorize it. So you might want to, for a while, stick to the algorithm here. But yeah, anyways, let me go over it with you first. So, first couple moves, you R prime, F, R, and then F prime. And then what you do here, now to move this, oh shoot. I forgot to mention what this does. So what this algorithm does, let me just do this real quick. There we go. So what this algorithm does, I forgot to explain, is it moves these 3 edge pieces nearest the key corner clockwise or counterclockwise. Before with my other algorithms with like checkerboard, cube and a cube, and anaconda, so you can see right here, I only had one algorithm where you would do it, well, checkerboard and a cube was moved the pieces clockwise, whereas anaconda moved them counterclockwise. If you wanted to change that, where it would move like counterclockwise or clockwise, you would move it to the other side, move to the other key corner, and do it respecting this key corner. But what is it? Yeah, in this video, these algorithms are so simple that we don't really have to follow that. And if you didn't really understand my mouthful there, you don't have to, so that's good news. Anyways, these three moved clockwise. That's what this top one does. And so, but, alright, so yeah. So if you want to move it clockwise, put the key corner on the bottom right, and then start off with like those 4 moves, I believe. To move it clockwise, you go R prime, and then F, R2, and then F, F prime, I guess that was before. And then you bring this down, M, is this M? I think that's M, yeah. And then you undo that, so it's F prime, R2, F, and then you bring it up, and then you bring both of these up, and then undo those 4 moves, and it moves it counterclockwise again. For counterclockwise, let me just do it counterclockwise real quick, that way it solves when it's done. There we go. For counterclockwise, you do it, what is it, this first algorithm, backwards. So in this case, start off with those same moves, but instead of going like R prime, and then F prime, and then R2, you know, what you do here is you actually move the, what is it, you actually, you know, at the end we moved R, is that R wide? Yeah, we do an R prime wide, or R wide prime. And then we turn this, F prime, R2, F, and then M prime, I believe, and then F prime, R2, and then F, and then we undo those moves, and there moves it counterclockwise. Bit of a mouthful. Just follow these algorithms. Do it a couple times in your 3x3. And oh, I forgot to mention this real quick. So here I move these clockwise. The important thing is, you might ask yourself, you might be asking like, why not just use the cube and a cube algorithm that I discussed last video? Well, it leaves the other side completely solved. An important point I forgot to mention. I'm sorry about that. Alright, now I'm going to undo this. So, yeah, it's a bit easy on the 3x3. Thing is, though, on bigger cubes like this, let me solve this real quick. Yeah, it's a little bit harder, you know. They're bigger, and like for this one, it's not exactly like, I don't think this one's actually really lubed at all. I lubed it before, but it's probably gone now. But yeah, for example, with this one, it's a little bit harder to turn, and I actually plan on taking it apart and cleaning it soon. So it's not so good with the finger tricks, right? And finger tricks are nice because you get the muscle memory. Big cubes are bad with muscle memory. So that's why, especially with big cubes, you might want to follow the algorithm. But yeah, but the cool thing with big cubes, I don't know if you remember, like, if you look here with, what is it, the cube in a cube pattern, you do, like, yellow here, and it turns everything else yellow. You do red, and then it turns everything else red, and whatnot, and you keep going down these, and then you do the corner twisting algorithm to do the rest. But that's like 12, that's like 10 algorithms right there. It's a bit long, right? And this one, what's really nice is you can just do the algorithm once, and it solves these 4 yellows, and then you can do it again and do these 3 reds, and then the rest, leaving the rest green. And there you have done this whole side in 2 algorithms, and if you do the same on the other side, that's 4 algorithms. Way less than these 10 algorithms. So that's really cool. I like that. So yeah, let me show you how to do it on a big cube. For a starter, let's see here. So start off with these. Let me see. 1, 2, 3, 4. 4 moves. All right. And then instead of like these M moves, whatnot, you don't move this whole side, but you select which pieces you want to be affected. So, for example, yeah, this is reds are bottom here. So, for example, I'm gonna try and swap this piece and this piece clockwise. So we do this, and then we move these down. All right, not the whole side. I wanted these 2 affected, so you move these 2 down. Move that, and then you undo it. Remember, you do R wide with both of those, and then you undo this. And there, check it out. We have done these. Well, what's that? 1, 2, 3, 4, 5, 6. Move these 6 pieces clockwise, and the other side is also completely clean, if you will, solved. So, so really cool. And then again, we can also like change these 2. I'm going to move these 6 pieces counterclockwise. So that's going to be like, this is red, so it's going to be green. So let's see here, counterclockwise. And then as an R wide prime, I do just a simple R prime with an M. Alright? Oh, this is our substitute for M. This is actually like 2L and 3L, I believe. I don't know. Big cube, what is it? Big cube notations. There we go. Yeah, and check it out. I did it. So, here, I was able to do these edges, and yeah, and like only do these edges and these 2 different colors in 2 algorithms. That's like 4, 8, 12 pieces that we've moved here. Yeah, so anyways, that's really cool. And a bit of a shortcut for, 10 algorithms, right? My gosh. Also, as for the corner, you use the corner twisting algorithm for the corner alone, too. Sadly, there's no way to twist only one corner, key corner, right? Can't twist this one and leave the other one untouched, I'm afraid. Anyways, that's that. Really cool. Let's get into the next 4 here. Yeah, one starting with F prime and then gets into D prime. So, this is what it does. I've got my key corner here. So, cool thing here. What is it? Another commutator. This one, take these farthest farthest corners from the key corner, right? And you move them clockwise. So that's what this first algorithm does of the 4, the last 4. All right, so let's see how. Let's start this. So it's F prime, and then D prime, and then R prime, U2, R. Oh shoot, this is R prime. 4 is R, D, and then R, U2, R prime, F. And there we have moved them clockwise. You want to move them counterclockwise, and you do that backwards. So that's F prime, and then R, U2. You see we don't actually do D prime first, we do that last. So that's R, U2, then R prime, then D prime, R, U2, R prime, D, and F. So, yeah. So this first one here of the 4 moves them those pieces clockwise, and then counterclockwise on the second. All right, and then now we're left with these last 2. So, quick note. Let's see here. Let's just do this algorithm real quickly. So here I showed you how to move these key corners. Corners farthest from the key corner clockwise, right, and counterclockwise. Well, if you look on the opposite edge, on the opposite key corner, we have actually moved these 3 corners that are closest to the key corner, not the farthest, but the closest. So, that's a bit something there. I'm losing my train of thought. So, what is it? If you want to swap these pieces, move these counterclockwise, clockwise. True, you can go to the other side, to the other key corner, and then do it, and then switch them around, or you can do it from this key corner, and that's what these last 2 algorithms do. Shoot. Here we go. That's what these last 2 do. It starting with D prime. It moves these corners closest to the key corner. So yeah, let's start off with this first one. I hope I do it well. I kind of just learned them. So we start here with a D prime, and then L, B2, L prime, F prime, L, B2, L prime, F, and D. And there, as you can see here, I actually solved them. Apparently they were moved counterclockwise, so now I moved them clockwise and solved it. If you want to move it counterclockwise again, you can do the algorithm backwards. And that's done with D prime, F prime, L, B2, and then L prime actually, F, L, B2, L prime, and D. And there we have moved them counterclockwise. It's really, really cool. But, again, you can always use this on bigger cubes. Big cubes, yeah. So, yeah. And the thing is, too, those last 2 actually, last 4 actually, is how I change the back edge. Right? So, for example, I'm going to try and make this whole area green here, right? I want to make these pieces green here. Right? From here to here. Green. So, how do we do that? That's on the back edge. So that's these first 2 of the 4. And that moves it counterclockwise. So that's the second one here. Alright, so, and here we go. So we do an F prime, R, U2. Oh yeah, and notice how it's kind of like a 3x3, but I'm moving 3 pieces at a time, or 3 rows. So yeah, F prime, R, U2, R prime, oh shoot, I'm losing my place. Oh yeah, R, U2, R prime, D prime, R, U2, R prime, D, and F. And there, check it out, I made this whole area green here. If you want to change that, don't worry. You can use the method for changing the center area without disturbing the other side. I'll get to that in a bit, though. And then, I don't know. I just for the sake of it, I'm going to make this piece red. So that's another counterclockwise one. So using the same algorithm, I make this very last corner piece red. So then, what else? I'm going to try and affect this area. Sadly, it will affect this area too. So like, for example, if I want to make, I'm actually going to make this whole area red, let's say. So if that's going to happen, this is the red piece. So see, 1, 2, 3, 4. I'm going to affect this fourth piece. So, and the fourth piece is here. So that's actually clockwise. So four rows at a time. I guess this makes it like a 2x2. So we move F prime, D, D prime, R, U2, R prime, D, R, U2, R prime, and F. And, oh my gosh, hold on. I did those. Yeah, I did the back edge, not here. So, D, clockwise, right? Yeah. D, L, B2, L prime, B, no, F prime, and then L, B2, L, oh shoot, I meant, B2, I'm getting, oh man, my head's getting fried, hold on. Alright, I'm back. Yeah, man, all this talking kind of wears you down. Anyway, so yeah, I want to make this whole area red, or at least most of it. I'm going to try this out. Red pieces are here. Oh, no wonder I went so wrong. I'm thinking back edge. Here. Back edges are here. So yeah, you do need to do it clockwise. So let's do this clockwise. I'm following the algorithm this time. D prime. Clockwise, right? Yeah. So L, B2, L prime, F prime, L, B2, and I believe, oh, I think I did it. I think. It's a little bit hard to notice because, what is it? Like green, for example, isn't there. So I'm going to try and undo this part. It's a little part. So let's do this counterclockwise. Alright, there we go. Oh wow, and what do you look at that? Really, really cool. Oh yeah. Yeah, for a second I was like, how'd this get here? But yeah, it comes with this whole thing. So yeah, what do you think so far? This is the other side. So much cleaner, and then it's like chaos. Alright. So yeah, I think I covered that well. I think we're ready to move on here, finally. So, you have your pattern here. You know, you did the edges. How about the center? How do we clean that up? How do we add to it? Good question. Here, this is how. This is actually a lot like the, what is it, the first two of the 4 algorithms. Let's see here. Yeah, you know how you, it works a lot the same way. It's another commutator. So I'm actually gonna, just do it over here. It's a lot easier to think. Anyways, so the area let's see here. So first of all, we do a setup move, you know, like so, like you're getting ready to move the piece over. But, well, for example, let's do this piece, right? Super simple. One way you can think of it is think of this piece. I actually kind of like to think of the face here for this. So let's move it counterclockwise. Forgot to mention. So blue's here. So let's make this piece blue, right? So we're gonna F prime. We're gonna do make this blue, right? So I'm not sure if you're into coordinates too much. It's very much like coordinates. So we bring it over on the x-axis, if you will, and we hit here this piece, and then we pinpoint it with moving it up like so, and then turning the top twice, and then bringing this down, bringing it back, and then we undo this move by putting it up, turning the top twice, and then down. And then we undo our set it move, and voila, they turned clockwise. It might be a little bit hard for you to grasp, but I highly recommend watching a video on commutators and practicing them a bit. It's very much a commutator. How about moving it counterclockwise, right? So we're going to move this, let's do an F prime here, and instead of aiming it up like so first, what we're going to actually do is put this up first and then turn the top, right? Doing this backwards, and then you bring it over, right? Then you bring it over, move this up, turn the top twice, undoing that, bring it back, and then turning it this 2u prime, I think this is, and there it is. It's solved. So really cool. And again, it doesn't only just work on this piece. You can fix up the rest. For example, yeah, fix up this these white and this blue. So it's oh, you could also do it from here too, by the way. But yeah, I'm gonna do it from here. Doing this clockwise, we push the orange over here, not yellow. I mean white. White and yellow, right? So we're gonna move this. We want to hit these 4. So you're gonna move these 2 rows up, and then turn the top, then back down, and then we bring it over, right? And then you could bring it up, turn the top, undoing that, and then you undo this move, and there we actually fix this up. We still got this piece, so let's fix that up. So moving it up. Alright, move these 4 up, turn top twice, alright, then we hit it, kind of like coordinates, you know, we're hitting all 4 of those. Moving this up and undoing that move, moving this down, and, oops, F. And there we go. We got, it's cleared, and now we have these pieces, right? Oh yeah, and to mention too, doesn't affect the other side as well. So, for example, I'm going to do these. It won't affect anything here. So let's do here. We can move it clockwise this time. So moving this clockwise. I'm going to do these 3 pieces. So you move 2D prime, I guess, yeah. And then we move it up, turn it twice, and then put it back down. Move this back, and like, oh dear, mind the jamming. Alright, and there we go. Well, let me just finish this up real quick first. And there, solved it. Solved the center area. Clears it up for you to do more. And again, if you look, didn't do anything to this side. Bit of a disclaimer though, real quick. For example, if you wanted to change the center, like say let's swap the center, or the centers. Let's make these 4 tiles blue, swatch them counterclockwise without affecting the other side, right? Let's try that. Thing is, with this method, you can't, with like, kind of like coordinates, right? You move these over and then you want to move these back up, affecting these. Doesn't work because when you move it back, when you circle this around twice, you come down with the exact same pieces. It doesn't work that way. So what you have to do, sadly, or however, you bring these 2 over, and then you have to do row by row. So for example, this one, you have to bring this up with it twice, and then do that. Alright, and so then move that piece, and then you can do the next piece. So it's like a 2-step process. I hope I explained that well enough. And so here I have moved the center pieces clockwise. So it's not exactly like a, it's not a 1-step thing, or in one move, whatnot, like before. What is it? Yeah, because these are equidistant from the center, if you will. Because they're parallel, it won't work, I'm afraid. So, yeah, you have to do it twice. The nice thing though is you can I guess I'll show it here. What is it? If you do this step, you move it up and turn the center twice. You can then do, after doing that, you can do it on the other one as well. And then you bring this over, and then you do this twice, right? So once. Alright, so I did that one, and then I can do this one. And then you can bring it back. So that's kind of nice. Still more moves, but I don't know. Anyways, I hope. Oh shoot. Sorry about that. Hold on. Alright. Here we go. I think we got it. When you're recording, don't hit the table too hard. Sorry about that. Anyways, I hope that wasn't loud for you guys if you had earbuds in. Anyways, yeah, with a bang, I guess, be concluding, except, oh yeah, I want to mention this too, real quick. Give me a second. Alright. Yeah, there we go. Sorry about the little tumble there. Yeah. My stand is a little cheap. My phone case. Anyways, since we're talking about double-sided patterns, no, double patterns. There we go. Anyways, I just wanted to share this algorithm. Really lengthy algorithm, I guess. Right here, it's this bottom one, and I've been discussing 3-colored patterns, like that. 3-colored, right? Going back, here's a little trip back to opposite colored patterns with this one. Yeah, kind of lengthy. I didn't memorize it, but cool thing. It's also in 4x4 notations. That is, it can still apply to bigger cubes like this. That is, if you apply the moves, That is, like, for example, this is 2U, I think, yeah. So, for like 2U, the second slice here, down from the top, if you wanted to mention, I show like a U2, a little U2, that's the equivalent of 2U, or it can be 3U for that matter, if you want. Anyways, yeah, another mouthful there. Anyways, let me show you what it does. Yeah, if you're not familiar with cube notation, with 4x4 notations, again, please watch a video on that. Anyways, give me a second. Let me just do this on the Rubik's Cube real quick. Alright, here we go. I just did it. So, length, the algorithm. Happy I did it right. So, this is what it looks like. Shoot, hope get the lighting right. There we go. So, as you can see here, what it does, it takes these three corners. It's kind of like this, the first two algorithms I discussed in this video, starting with x prime. What is it? Yeah, it's kind of like that, where it moves these pieces, like so, the front pieces. Thing is, though, interesting thing is that it affects the other side differently. Turn it. As you can see here, they're a little farther apart, farther from the key corner, whereas over here, they're right next to it. So, interesting thing. Yeah. So, that can get, what is it? If you want to, you can use that. I think you'll enjoy it. And it'll come in use for, let's see here. Yeah, 6 colored patterns, or double pattern, opposite colored patterns. Yeah, double opposite colored pattern. Huh? I don't know. Anyways, man, 40 minutes, right? I'm so sorry about that. Really love getting into these. Love these Rubik's Cube patterns. Still new to the recording thing, right? But yeah, anyways, I hope you enjoy it. I hope you can apply it, you know. They can look really cool. Like I have this is like a mirror block, I think it's called. I love calling it a mirror cube, but it's technically called a mirror block, I guess. But yeah, anyways, I did an anaconda on it. It makes it look really cool. But yeah, anyways, really cool stuff. That you can apply here, even if you're just a speed cuber, you know. I hope you can apply this. Really nice. Nice commentators. As for next video, what's up with next video, right? Here's my junky 5x5, if you remember. And I've been, I like to use it to demonstrate what pieces are really affected here. Yeah. Anyways, what pieces are affected? Here, this is actually an example of a two-way symmetric, reflective symmetrical, three-colored patterns. You know, on what pieces you can change. And then the red area is the pieces that are affected from the yellow area. Pretty cool. My next video kind of gets into this. It really shows what pieces are affected and whatnot, and how to record them. I showed earlier in my last video, actually, I think. Yeah, is it my last? It was my last video. I discussed how to Rubik's Cube patterns, you know, how to write them down in your notebook and whatnot. That way it saves more space than a picture, right? A lot of people take so many pictures they don't have any room for them left, right? Good news, you don't have to take any more pictures. You can just write down the pattern you want to do. Unless you want to take pictures of it, that's perfectly fine. Anyways, in my next video, I'm going to be talking about that. How to make, write it down. Write down the pattern. For example, like this one, I guess you can write it down now, you know? Into little numbers like that. Allows you to do the pattern later or something. I don't know. Anyways, really, really cool. I think you'll find it really, really useful for Rubik's Cube patterns. So, yeah, until then, take care. Hope you enjoy your patterns. Take it easy. And don't break your Rubik's Cube in frustration. Alright. Again, thank you so much for watching. and getting this far, really. So, see you guys in next video. Later.